Okay, so as I've been going through conic sections, maybe you've been asking, why are we always looking at two cones right on top of each other? Why not just one cone? Well, the answer to that is because we could have this situation here. So this is called a hyperbola. Hyperbola is when we take this plane and we run it perpendicular to the base of the cones so that we get sort of this basketball, um, like almost like the 3 point line sort of symmetry there. That's going to be our hyperbola. Now the plane doesn't come along with it. It's just these lines that will give us that hyperbola. So here is the hyperbola, and it's just a set of points whose difference um, oh whose di- the difference of whose distances from two distinct points, the foci, is a positive constant. So before we had the ellipse where the sum of the distances was the same. Now it's the distance. Right, so d2 minus d1 is a positive constant. A couple other pieces of vocabulary. So the focus, just like with our parabola, is on the inside here. There's this dead man's land in the center of the two hyperbola, of the hyperbola, which is we call the center. The distance from the center to each vertex is a, and the distance from the center to each focus is c. We call this major axis here. We call this the transverse axis. It connects the foci, the vertices, and the center. So here are your two equations, not to be confused with the equations for ellipses, where we had plus signs in here. Now we have minus signs in here. When the transverse axis is horizontal, so when we have these hyperbola open up just like this, that means that we have the a squared with our x value, and with the transverse axis is vertical, so functions pretty much. Well, not actually, they wouldn't be functions because 2 points, vertical line test fails. But here, whoops, I drew that line wrong. Here, we can see that this is vertical, so y-axis, a value, and that's how we get that. Okay, so here we go. We have the center is at h comma k, so that means that when we have this horizontal transverse axis, the focus is going to be at h plus c comma k and h minus c comma k. And here, because we're adding that c value onto the y value, it's going to be k plus c. All right, so we want to find the standard form of the equation of the hyperbola with foci at -1, 2, and 5, 2, and vertices at 0, 2, and 4, 2. So noticing that the vertices are at 0, 2, so 0, 2, and 4, 2, and the foci are at -1, 2, and 5, 2. Right, we have this horizontal lining. So we know we're going to use this formula here. So x minus h squared over a squared. And then it's going to be a minus in the middle, so minus y minus k squared over b squared is equal to 1. Now the center was not given. That's going to be our h and k. Well, it's going to be halfway between these two. So if this is 0, 2, and this is 4, 2, right in the center is going to be 2, 2. So that means that that is our h and k value. So the distance from that center, so 2, 2, to the vertex, that is going to be a. Yep, that's a. And then the distance from that to the focus is going to be c. Now I know what you're saying. Where does b come in? Well, I think I skipped over that piece. No, I guess I just did not include it in any of my slides. Well, here, this is our good old friend, a squared plus b squared equals c squared. So we're going to have a is going to be equal to 2. C is going to be equal to, the distance here is 2, 2. Go to 5, 2. C is equal to 3. So 2 squared plus b squared equals c squared. So b squared is equal to 5. So we get x minus 2 squared over 4 minus y minus 2 squared over 5 equals 1. That is our equation from these values there. So let's look at some other values here. Oh, asymptotes. Yeah, so remember we've looked at previously horizontal and vertical asymptotes. Well, here we're going to be looking at these diagonal asymptotes, which these the hyperbolic curves are going to hug as they go through. So the equations are going to be these values. So k plus b over a times x minus h. So I think we have a question. Yeah, so we're going to sketch the hyperbola whose equation is this. So yet again, we want to make this into fractions. So we get x squared over 1 minus y squared. Getting ahead of myself here. Y squared over 4 is equal to 4. Sorry, I did that wrong. We want to divide by 16. 16. Because we want this equal to 1. So we're going to get x squared over 4 minus y squared over 16 is equal to 1. So here, a is going to be bigger. Sorry. Not necessarily. So, yeah, notice this is a minus sign, right? So x minus y is going to be this horizontal. So because we have x minus y, it's going to be horizontal. So this right here, just like in this equation, that's going to be our a value. This is a squared is equal to 4. And this is, b squared is equal to 16. So let's the center is h comma k. So h comma k is going to be 0, 0. And so what we want to do is we want to figure out well, let's start graphing. So we know we said this is going to be horizontal. So the 0, 0 is the origin. So a squared, this is the distance to the vertex. So a is going to be 2, so 1, 2. So there's one vertex. 1, 2. There's the other vertex. Then we want the foci, which are going to be distances of C. So we're going to do a squared plus b squared is equal to c squared. So that means that we get 4 plus 16 is equal to 20. So c squared is equal to 20. So plus 2 root 5. So the square root of 20 on both sides. So the square root of 20 is just a little bit over 4.5. So there's 1, 2, 3, 4. So right there. 1, 2, 3, 4, right there. So focus, focus, vertex, vertex, center. But now how do we decide what these curves are going to look like? Are they going to look like that? Are they going to look like that? Well, that's where we need to figure out what our asymptotes are. So here, when we have this horizontal transverse like we do, y is going to equal k plus or minus b over a times x minus h. So y is equal to, actually move this out of the way. So to find the asymptotes, we're going to do y plus or minus, sorry, y equals k plus or minus. Y equals k plus or minus b divided by a times x minus h. Okay. So k, we know is 0. So plus or minus b is going to be 4, a is going to be 2, x minus 0. So we're going to have y equals plus or minus 2x. So if this is at the center, the origin, so 1, 2, 3, 4, 1, 2, 3, 4. So if I graph this, starting here, 1, 2, right? Usual slope formula, rise over run. Down 2 to the left 1, down 2 to the left 1. So there's one asymptote, and then the other one has a slope of -2. So down 2, right 1, down 2, right 1. And make the best I can. So then this is going to hug just like that. And there we go. It's not a work of art, but it'll do its job in showing us what this is going to look like and what those points are.